Hello, this is Martin Osei Jr., a mathematics teacher. In this video, I would like to show you the simplicity of editing scientific documents using ScienceWord 6.5, a new generation word processor that allows you to edit in the same environment ordinary text, mathematical formulas, complex chemical equations and molecular structures, geometrical constructions, and animations, experimental setups, function graphs, elementary school vertical calculations, etc. The current interface is what you see when you open ScienceWord for the first time. For the purpose of this video, I've customized a menu which I am going to bring out. So I right-click here, go to Customize, and then I pick my Demo Tools, which is a menu I've customized. If you double-click it, it appears up there, so you can now close. Let's start with how to type mathematical formulas in the most natural way. In this approach, we use the name of the symbol or formula we are about to type. In this instance, we have a symbol we call the long left-right arrow. I will start by pressing the backslash. And once you press the backslash, you see a menu pop up. Then I type long left. I've not even finished typing, but you can see the symbol appear. I'm going to select it by pressing the number that corresponds to the symbol, and you can see the symbol appears. In teaching, we refer to it as if and only if. So if I should type if and only if, it also appear, and I get it. We can also use the abbreviation IFF. And as you can see, when I type IFF, it also appears. Let's not forget our secretaries, who would rather put together a less than, equal to, greater than. And here we go. That would also give it to you. No sweat at all. For those of you who would like to customize it, give your own names, you can also do that. You do not have to stress yourself and memorize any of these. If you'd also like to go and click, yes, you can go to the tax pane, go to symbols, and then if you should go through down there, we should find it somewhere. Yes. Here it is. Just click on it and you have it. You can also go to the menu up here, click on these arrows, or you can even drag the menu out, put it beside you for convenience sake, where you can pick several times, and there you go. If I want to write this greater or equal to, I can decide to use the AMS style syntax, GEQ, that is greater equal, GEQ. So I type GEQ and I get it. I can also decide to spell out greater or equal to completely. As I start typing, you can see it appear. So yes, I click on it, or I can also decide to just use from the keyboard. I press greater than and then press equal to. Once again, I can get it this way. The same way, if I want to type square roots, I type SQRT. If I should make any mistake, I just clean and then go back to retype SQRT after I press my backslash, and then I can get it and type whatever I need to type into it. Or I could spell it out entirely, just as I did with the greater or equal to. I type SQUARE, that is square. I spaced up and then try to type the roots, but you can see it has already appeared, so I can pick it up from there. So as you can see, no more constraints. You don't need to memorize any single sentence. Next, I have for you the most cunning way of inserting elementary school vertical calculations in our text. I'll go to this menu I customized and pulled out. Let's say I want to have 342 divided by, let's say, 76. I would like to unshow border, and then I just confirm. click anywhere on the screen, and there you have it. I can pick this and then, let me say, duplicate it and then make some changes to it if I want to. So I can take a duplicate and then right click, go to properties. Let's say this time I want French division. So I click French division and confirm. It changes to a French division style. The same way, if I want to factorize, let's say, which number should I give? Let's say 10101. I uncheck show border again, and then I confirm. This is the factorization. It gives you all the prime factors. If I would like to, I can still make a duplicate of this and then go to its properties where I can make so many changes. Any change I want. Well, let's say I wanted to have the same division or horizontal lines, and then you see it there. Let me say I want to also take let me take another duplicate of it again, and then go to properties once more. I go to properties, and then let me change the vertical spacing to 0, and then let's show French division. No, let's show division line, and then let's say factorization. Okay, let's try this. Let's see what we have here. Okay. I didn't take the French. Let me go and check the French division, then confirm. So yes, here we have it once again. Let's see a few tricks in drawing as well. Let's say let me draw this triangle. Now you can notice as soon as I draw a triangle, you can see so many tools pop up in the geometry toolbar. If I want to display the perimeter, I just click on perimeter. This software just understands the natural way of working. Let's say I want to circumscribe the triangle or inscribe the triangle. I inscribe a circle simply by clicking on the tool. Okay, so next, let me try to draw an extension to the line AC. So I just pick a line tool, come to A, and then whilst I am drawing it, it asks me, do I want a line extension? If that's what I want, I just release, and that's a line extension. Let me just close it up a little. Let's say I want to draw a parallel line to AB starting from the endpoint or touching the endpoint. So I select AB and then go to pick my line tool, come to the endpoint of the extension. Then I try to draw. Once I stay in close to parallel direction, it will ask me if I want parallel. I want it, so I just release, and that is it. Okay, so let's say next I want to, let's say, draw a perpendicular line to this line I've just drawn, but passing through the end there. So you just have it. Okay, what should I do next? Let's see. Okay, so let's close. Let's delete this perpendicular. I don't need it here. And then let me make this line a little more bold, increase the width. I'll use 0.75 mm. Yeah, that's good enough. So now I'm going to define a vector from this point to that point. Let's just click those 2 points in the order I need it and click on define a vector. That's the vector from A to D. Now I can use this vector to translate any object. An example is the line AB. I can translate this line AB with the vector. When I click translate by vector, it asks me which vector. That's the vector I want. So I click OK. So that's my vector translation. Then I want to put a point on this vector, the translation. So I have put a point there, and then I want to animate the point. So I've gone to insert an animation button for the point. That's my animation button. Now I can select that point and maybe the point at the far end there. And then I want to insert a spring between them. So I just click on the spring, and then you have it here. This spring, I can readjust it to any form I want, increase the number of coils, the size, anything. You see those dots, black dots, I can use any of them to make those changes. I just have to keep readjusting them to the exact specifics that I need it. Okay, let's say I want it this way, and then the point is not very visible. Let me make it a little bigger by putting a circle, a small circle on it that makes it like a ball. And then let me color the ball. Let's say blue. Let's have a blue ball. So yes, that's my ball. Now let's animate it. Okay, the speed is a little low and then it's going one direction. So let me go and change the direction to both ways. And then I will increase the speed to, let's say, 4. And then voila, there we have it. That is it. Very, very simple. Now let's try something a little bit in, let's say, chemistry. Let's try chemistry. So I go and then pick this regular polygon and then put it down here. Let me go into continuous mode so that I wouldn't have to pick the bond several times. When you come close to a bond joint, it shows a red cross. It means it's ready to bond. You just click and then draw your bond in the direction that you need it to go. You can draw as many bonds as you want. And then let's go pick some chemicals. Let's say some element carbon. I bring it to where the joint is. When the red cross appear, I just click on it and there you go once again. Let's pick something else. Let's say hydrogen. Put a hydrogen here, maybe one here. I just want you to get the principle. We are not going to go too deep. I'm bombarding you with so much right now. Don't worry. We will try something else. Let's see. So many you can try. You can try your hands on any field that you find yourself in. Trust me, you have yours right here. So let's say I pick one of these hexa. Can you see that? Can you see that? Let's move this a little away so that we can see what we have here. Let's draw something else. I go into the chemistry apparatus and then electron distribution graph. That gives me by default ion. I can expand it or reduce it if I want. I can go to its properties and then customize it into any other thing I want. So over here, maybe I don't want ion, I want aluminium, Al. Once I confirm, the configuration changes to that of aluminium. And you can see so many other things that can be done with this ScienceWord. The scientific editing here is marvelous, no matter how complex, no matter how difficult you think your document is, you can easily work on it in ScienceWord. I would like us to try something in technical drawing as well, but I'll do that in teaching mode, where I can have a larger screen with much more convenience of work. With technical drawing, I need a lot of room to work in. So let's stay in the teaching mode, where presentation is another level altogether. Okay, so let's take a look at this drawing. Let me start by moving it out of text. Currently, it's in text and it's being considered as a character, like any normal letter. It can be copied and pasted anyway. But then let me move it out of text so that I can manipulate it a little bit. And then I'm also going to show you the various data that were used to construct this drawing you see there. Here is the data. And here are some animation tools that I am going to apply as well. If I want to, let's say, animate the variable L, do you see what happens to the diagram and all the various data? And I can even give it a specific value. So let me give L, let's say 0.8, and then you can see the reaction. Everything changes accordingly. Now I can hide it. I don't need it here anymore. In the teaching mode, I can customize it anyway. Let me bring back the geometry toolbar, and then let me go and put it at the top there. Let me go and put it at the top. Yeah, that's good. Let me even hide these buttons. I don't need those buttons anymore. So I've hidden them now. And then let me insert the drawing back into text. So the drawing is back there. Now let me show you something else. It does not matter which discipline you are learning. ScienceWord makes it very effective. Knowledge is more fun to learn and easier when students can now visualize, see the real life nature of problems instead of just imagining it in the abstract nature. Below are just a few examples. Let's see the animation of drawing of Lewis dot structure of the molecule of carbon dioxide. You can see the carbon and oxygen atoms coming together to form this covalent bond. If students can see this, they are never going to forget what they learned. They can see how exactly it happens. One of the reasons why mathematics has been seen to be so difficult by students is because of the abstract nature. Let's see how we can use the periodic function in a real life situation. And you will notice that students are enthusiastic about learning mathematics when they understand the concept they are taught in real practical life. See this problem being animated. And look closely. You will notice that as the drops of water drop into the container, the reaction is random. ScienceWord is powerful, I tell you. ScienceWord is extremely powerful. You can do so much that will blow your mind. Okay, so let's see another way in which we are going to deepen our real-life application of abstract problems. We are going to understand problems some more. So let's see the circle and ellipse. Consider any two chords of the ellipse perpendicular at the point O, which is the origin. Let's designate one end by A and then the other end of the other by B. Okay, next, we are going to prove that AB is tangent to the circle. Let's take a look at this diagram very well. Okay, so let me animate B and C. As it animates, it still remains a tangent. AB is still a tangent. If I animate C, it still remains a tangent. Even if I should animate T, it still remains a tangent. It will always remain a tangent. Another interesting thing that you can note is that it can be concluded that the point of intersection of the perpendicular with the ellipse are the vertices of a rhombus whose inscribed circle is the circle C that we've just looked at. You can take a close look at the solution. You can even pause it if you need to look at it closely before you move on. How? You can join me anytime and also visit the website www.scienceoffice.com to download the Learning 6.5 suite or client and the help book. You can also download the Learning 6.5 suite or client from www.novatest.com, where you can create and manage your online class from the website. In my next video, I'll be showing you the case of online assessment of scientific knowledge using the Cambridge University entrance test. Thank you very much for watching.